In this video, I'm going to evaluate the integral of 2x plus y dx plus xy dy along the curve C, where C is the curve which is appearing on the screen there. This is a curve which is starting from the point minus 1, 2, passing the point 2, 2 to the point 2, 5. So we have that curve there from minus 1, 2, then passing through 2, 2, then go to 2, 5. For such line integrals, it is convenient to split the curve C into two parts, C1 and C2. So the curve which is running from the point minus 1, 2 to the point 2, 2, I'll call it my C1. Then the curve which is starting from 2, 2 to the point 2, 5, I'll call it C2. So for our integral of 2x plus y dx plus xy dy along the curve C, it will then become the integral of 2x plus y dx plus xy dy along curve C1, then plus the integral of 2x plus y dx plus xy dy along the curve C2. Then we'll go on and analyze those two different curves C1 and C2. But looking at the curve C1 there, we see that y is equals to 2. Y is not varying. Change in y is 0. So what we'll be saying there is dy is equals to 0. And we see that x is varying from minus 1 to 2. So if x is varying from minus 1 to 2, if we are looking at the integral of 2x plus y dx plus xy dy along the curve C1 there, we are saying our x is varying from minus 1 to 2 and our dy is 0. So if we substitute into this integral there, we would have the integral from minus 1 to 2 of 2x plus 2, because we are saying y is 2, dx, then plus x times 2, because we are saying y is 2, then multiplied by 0, just because we said dy is 0. There is no change in y. So that will simplify to the integral from minus 1 to 2 of 2x plus 2 with respect to x. And when you evaluate that integral there, the 2x, it gives us an x squared, then plus 2x, then we put in the limits there, and the result that we get is a 9. So the integral along the curve C1 there is giving us a 9. We now go on and look at the curve C2. Along C2 now we see that x is 2. It's just constant, it's not changing. So if x is not varying, the change in x is 0. So we would have dx is equals to 0. And we see that y is varying from 2 to 5. So when you are looking at the integral of 2x plus y dx plus xy dy along the curve C2, substitute these values that I've just listed here, would be having the integral from 2 to 5 of 2 times 2, because we are saying x is 2, then plus y, then times 0, just because we said dx is 0, then plus 2y dy. The part where we are multiplying by the 0 there, it will just be a 0, so we remain with the integral from 2 to 5 of 2y dy. The integral of 2y there gives us a y squared. So y squared, then put in the limits 2 to 5. The result that we get there is a 21. So the integral along the curve C2 there, we are saying is a 21. So we have obtained the integrals along those two curves that we had split. But for our integral there along the curve C, we are saying that is the sum of those two integrals which are above, of which this one here, we are saying that's the 9, and this one there, that's the one which is giving us a 21. So to get our line integral that is required, we add those two, it will be 9 plus 21, which gives us a 30. So we are having the integral of 2x plus y dx plus xy dy along the curve C is equals to 30.